saw this just the other day. When you do this, you want to serve your Powershell module yourself. An easy way to do that is just like a Python server, or you probably want to serve it with HTTPS, so it's a little bit harder to see and detect on the network. But Matt Graber, he put this into the GitHub, I think recently. It's kind of funny. He's saying, don't just run stuff off GitHub. And a lot of security people, it's amazing that they do that. So he put at the bottom, throw something terrible that just happened because you did that, with a public GitHub that you don't control. So it's kind of funny. It made me laugh. But I think he said he was trying to give somebody a mild heart attack, because there's a lot of examples out there where they're actually pulling it down from GitHub instead of their own server. So he's not a fan of that. But, so setup. That was, set up to serve, just from the Powershell directory. And then this is setting up a Meterpreter listener, something I'm sure everybody's pretty familiar with. This is the actual PowerShell to run. So you have an attacker machine and then the victim machine. So this is actually run on the attacker machine to remotely execute code on another victim machine. So you're invoking the command on .139 there. And then you're downloading, pulling down the invoked shellcode and executing it with the Meterpreter, HTTPS, and the parameters there to do that. So it never writes to disk on the victim machine. There's nothing there. So this is just an example of when that runs. And I'm sure this is kind of something we've all, the guy in the corner every time. We've got Metasploit to work the first time, or Meterpreter probably still do whenever it works, get pretty excited. But a lot of these memes, by the way, are from InfoSec reactions. It's like one of my favorite sites, so definitely check it out. There's all kinds of really fun stuff on there. So anyways, the Meterpreter session got set up and just ran a couple, sysinfo, checked out the processes. You can see LSAS down there at the bottom, 512. And then, so then we're actually going to migrate into LSAS. And you can see that we're now in there. So if you're, looking at, say you see some suspicious stuff and then you go and you want to look at the server, you're digging in, looking at it, you're not really going to see anything. Like, it's no problem, it's cool, bro. Like, nothing going on. Obama's pretty excited about it there. So what's really going on is a reflective DLL injection. This chart kind of is there just to show what's going on. It's using virtual allocx to allocate space in another process in Windows. It's kind of amazing that you're allowed to do that. But then you're going to write the DLL into there and run it. So that's kind of how that's working in the back end. But. So like we said, there's no binary to disk. There's not a lot to look at, but volatility to the rescue here. So we'd run that malfind plugin that we talked about earlier. It's going to go through and look for injected code on a box, and it's going to pull back. This is like one of the examples that I found here. And then, like I said, look at the disassembly. See, some of these could be, but maybe dig in more on that one. And then further, you'd be able to see this with like the live IR script, looking at all the network connections as well. But just wanted to show what you could do in volatility with it, doing net scan. Why is LSAS, talking to another box on port 8080? Like, it's not normal. Definitely bad. This is another example with PowerShell, and this one's kind of almost even worse in some ways. It's almost like kind of cheating, I think. But so you're able to run Mimicats 2.0 and invoke a reflective PL injection from there. So you're reflectively loading Mimicats. You're not writing anything to disk, and you're able to dump creds remotely. So if anybody's not familiar with Mimicats, it's a really cool tool. You're able to run it and basically dump hashes of all the credentials on the box. So just like how we did with Powershell, you're running it, you're invoking on another machine there. You're downloading what you want, and then just invoking it and dumping the creds. So, and then just the gorilla's like, oh, give up. But this is just kind of the output that you'd get, hashes on the attacker's machines, what you'd see. So, like, not a lot to go off, right? The attacker ran it, he got the creds. There's some network traffic maybe to look at, but PowerShell does it over like HTTPS on a couple different ports by default that maybe you're able to start looking for internally. You start seeing that in between hosts. That's bad, something to look at. But what if we know something went bad and we want to look into it more? And some PowerShell memory artifacts that are there. So when you run a commandlet in interactive PowerShell, it's going to run in the WSM prov host.exe. And you're going to see the remoting protocol XML in there, some research that FireEye put out at Black Hat a couple years ago or a year ago maybe now. They went through and looked at a lot of this stuff. But the problem with that process is as soon as it closes, it's gone. But there's SVC hosts for the WinRM service. That keeps running. So that's an interesting one. It can contain some of the web services management SOAP messages for the remoting. And in some of the tests they took a dump immediately after running some commands and looking for the strings in memory. And then they also ran it 5 hours after. And then they did it a week after, and there were still some remnants in memory still after a week. But that's kind of dependent on how much WinRM activity there is replacing that memory. So this is an example from that Mimicat. It's where we ran. It's hard to see in there, I guess. So here, just listing the PS tree, finding the SVC host for the WinRM service, and then dumping that, and then just looking through it in the hex editor, and you're able to see a lot of the stuff for the commandlet there. So then also this one was taken immediately after. Didn't replicate some of the testing with like time delay, but with memory forensics, time is kind of always of the essence. Over time, things get paged out or are gone. So imagine that Dave Kennedy just walked in the evil uses slide. Some evil uses for some of these memory forensics that like bad guys could actually use it for, or if you're a offensively minded security researcher, dumping hashes from vmem files. Say you encountered some backups and a bunch of vmem files or some VMware stuff, vCenter, and also a lot of people sleep their VMs, so they're going to have the memory, the raw dump right there. So this is showing volatility, how you would dump the processes, or dump the hashes there. So you're just listing the registry hive and then getting the offsets so you can plug that into the hash dump plugin there in the bottom. And I kind of tried to obfuscate a couple, because there's probably a bunch of hackers out there, you guys. So, and then also Truecrypt can be, dumping that, it can be used for good, in a forensics case, or potentially, you could get into somebody's encrypted container. This one, you're just running Truecrypt summary on a memory dump. You can get the password right out of there. It's Jared Hart's Emmett. And then there's a 0 day in there as well for Emmett. It's a joke, but and then you can dump the key as well, the Truecrypt master key, right from memory dump. Let's see. So moving on, another example, Project Hook, point of sale malware. This is a RAM scraper. This is another example of kind of how malware could use memory. It can be used for good and then also for bad. It's looking for credit cards in memory. It was originally kind of reported on and looked at by Zylobox. There's a link there. And when we're looking at malware, something I learned from Lenny Zeltzer is using mind maps Really big fan of them. So when you're doing like a malware analysis, it's really easy. It's hard to see here on this image. We'll zoom in onto some of them, but when you're doing an analysis, just to kind of break it off, and then it's really easy to do like a tree and break it down all the different parts about that malware that you might want to know or maybe come back to in the future to look at. So this is kind of just zooming in on a part of it. So like the mutex, grabbing that, putting it into a mind map. Some of the network traffic. You can also dump files right into like an Xmind mind map. So screenshots as well there, as well as some of the requests, the get and post. The get request there is right upon infection when it happens. There's the get, and then the post is actually, we'll dig in farther. When it finds the credit card, it's actually going to post that up to the malware C2 server. So, and then this is kind of cool. I like it when malware authors leave little kind of, I don't know, Easter eggs or little things maybe they're using when they're debugging the malware just to have in there. So when you're debugging through this malware, there's a jump that is always taken there, or jump equal short, whoa. And if you don't take that jump, actually, it's going to launch up a GUI. And so when you're debugging, you can make it not take that jump, and then you're going to get this little GUI, and it's going to show you each process it's scanning as it's going through. It's kind of cool. Neat little thing to point out. But digging in further, looking at the kind of mind map here and some other stuff, that you'd want to document when you're looking at a piece of malware, either that you dumped from memory or just in general. These are some of the things I like to write down about it. And also you can kind of like plus and minus, like open and shut different areas to kind of make it less busy. So then this is kind of just a bunch of screenshots from using OllyDebug. It's a debugger. It's used. It's probably one of the most popular ones besides WinDebug, maybe. WinDebug's a little bit steeper learning curve to use than OllyDebug. OllyDebug's really simple, so if you guys are getting started in debugging, it's a good one to play with. So this is kind of like, I just mapped the functions. It's way too small to see, it looks like up there, but we'll zoom in. Yeah, it's kind of too small there. So basically the malware, it's going to copy itself to a new location, is what it was doing on this page. And then it's going to put a file there, and if that file was not there, it's going to dump it, and then it's going to do that notify get request telling the malware author, hey, I'm here. And then from there, it's going to do some other things and start checking for credit card numbers. It's looking for the track 2 credit card information. It's going to, so when it finds something, kind of is checking for the beginning part, and we find something that looks like it, it's going to then check it with the LUN algorithm. That's an algorithm for credit cards, if it's actually legit. And then once it verifies that, it's going to then upload it to the C2 server, performing that post. So this is kind of the example screenshot from OllyDebug here, just where you can see the server in there, and then also the call to upload it there. And then this is an output from Wireshark of the earlier get request. So anybody that's interested in playing with malware, a lot of times it needs an internet connection or some sort of network, but that's usually a bad idea. You don't want these guys knowing where you're coming from, or allowing a system, even if you're doing a safe VM, to connect out to the internet, because then the bad guys maybe know that you're looking at it. So there's a really cool tool called FakeNet by Mike Sikorsky and Andrew Honig. I think he was here last year. Mike Sikorsky kind of showed some of this. I'm sure you guys are familiar with it. But this is just, it actually saves a PCAP. It'll simulate a network and then respond to requests and then save everything off to a PCAP. So this is just an example of the GET request in Wireshark there, saying, hey, I'm alive. We got an infection. It also pops up a message box. So kind kind of some closing thoughts, and I have a few other slides on this. So closing thoughts on memory forensics. If this is interesting for you, I'd recommend downloading it, Volatility from the Volatility Foundation. There's like a whole slew of sample memory images to play with. And then, like I said, the book, Art of Memory Forensics, is super detailed. It's like 900 pages long on memory forensics. And also, it covers a lot of stuff with OS internals that you're going to need to know for memory forensics. And then also, you're able to dig in then looking at volatility, like we mentioned earlier, to look at Windows internals and learn Windows internals. Looking at the source code there is really awesome for that. And then just play with it. Like I said, get those memory images, make your own dumps, and play with it. That sounded funny, make your own dumps. But so this is like one of my favorite memes. I had a few memes in here that I'd like to kind of close with. A few protections that I think are really effective for an organization to do. So definitely whitelisting is really huge. I think we've been learning slowly in security that blacklisting really isn't working. So that's, an antivirus signature, applied in like a broad context. So, really whitelisting. So that means like application whitelisting, not just antivirus, right? So things like Bit9. Also, there's some built-in ones. But then also be careful not to have bypasses there. Disabling PowerShell. We looked at those PowerShell attacks. It's definitely really dangerous unless you need it, or maybe not for normal users. Disable it. Java is another bad thing. If you need it, whitelist, virtualize. Another thing, organizations kind of bypasses on a network whitelisting. There we go. So whitelisting on a network, in and out traffic as much as you can, proxying outbound traffic, trying to prevent. We looked at some of those Meterpreter shells, a lot of malware. It needs to communicate out, so if you can break that somehow, that's always a good thing. And then application security. A friend of mine, Damien Profantic, he has a whole huge talk on that. If that's interesting to you, on blacklisting. Basically doesn't work, and he's got all kinds of bypasses for like WAFs and all kinds of stuff like that. So, in application security, whitelisting is really important as well. So. And then continuing on, segment all the things. These are kind of like basic security things, but we're looking at some of the real kind of the deep end kind of things with memory forensics and like reversing, but it seems like a lot of the basic stuff, you see a lot of the breaches, a lot of like the real basic things are getting missed, and that's a problem. So segmenting like a ship that's going down, the Titanic or something, being able to segment off different areas, super important. Different accounts, local admins. You don't have the same local admin all the way out throughout an organization, because like we looked at like Mimicats, if they're able to get that, they're able to get like everything from there. And then different accounts for normal and admin usage. And then also segmenting. Big fan of multi-factor authentication, segmenting out as much as you can. Different trust zones, not only just the internet, but if you have an area that is really important for your business, you really want to segment that out with multi-factor, even internally. I think that's a really good thing to do. And not just by itself, it's something you also really want to train your users on, because multi-factor is not perfect. Can definitely be social engineered. Some of the ones where you just click yes, maybe it keeps popping up for somebody, they're going to click yes, or a PIN, getting called and asked to give up a PIN. So it's definitely important to do like your social engineering testing there still for segmenting. And then the last one, kind of a huge focus, you start to see in the InfoSec community, like working on detecting. We have all these tools and things that we're using. We really got to have people looking at the logs and looking at everything to actually find this bad stuff. So as we looked at, some of those examples of the malware, like actually doing like active hunting and looking and trying to find some of this bad stuff that might not always be there on a surface look. A lot of organizations, I think there was some stats that was like over 200 days before knowing when they've been hacked. So really, taking the time to look at stuff really needs to be more of a priority. Also with detection, so some really cool strategies with detection. I've been hearing about recently doing things like honeyports. John Strand talks about a lot like that. Project Artillery, Dave Kennedy, another one he has out there. It's really cool for just like actively kind of putting something out there for people to connect to, and not a normal user would connect to it, right? So like maybe a darknet, an IP address or something that nobody should ever be connecting to, and if somebody does connect to that should be like an alarm to look at something. So that's a really good strategy. Also, Bro, IDS, some of the PowerShell remoting things that we talked about, maybe using that to look for some of the communication between hosts, or maybe from a VPN to inside, looking for those things, as well as monitoring exfiltration is a big thing. Like the Sony attack we saw recently with Sony getting attacked and like all kinds of information getting out. Really have to be looking for data going out. And then also we kind of mentioned hunt teaming. So Google Rapid Response, talking about, does it scale? That'd be a tool you can scale with. Facebook has a really cool tool as well called OS Query for like Linux and Mac. It basically allows you to query your OS with SQL type commands. So, if you guys have a Mac, it's really easy to install. Just brew, install OS Query, and you can start tinkering around with it. But so you're able to like select whatever fields you want on OS and dig in from there. So references for the talk, and then I found that on Twitter. That's from Halloween. But so thank you guys.